Good morning, Math 20s. We're moving on to the unit of trigonometry, and the first lesson is on page 137 of your workbook. This will be the first part of two parts for this lesson. A couple of things I wanted to point out before we actually get started into this lesson is I need everybody to take out their calculators, and we need to make sure we're in the correct mode. So your calculators, the default or factory setting mode is in radians. So every time you clear your calculators, it's going to go to radian mode. Radians are something we deal with in Math 30-1. At 20-1, you need to be in degree mode. So click the mode button on your calculator, and then scroll down to where it says radian and scroll over to degree, highlight degrees. From here, just hit second function quit. And to do a test that you're in degree mode, I always tell students to type in the sign of 90, because if you're in degree mode, the sign of 90 is 1. So type in the sign of 90, and if 1 comes up, you are in degree mode. The second thing I want to point out is as we go through these notes, you're going to see these video lists. What these are videos to Mr. Prema. And the reason I tell students to watch these is Trig is arguably the most important unit in 20-1 that you need to get into 30-1. So by the time you get to 30-1, Trig will be a quarter of the course. 2 of your units are going to be on Trig. So students just have to have a really good understanding at the 20 level in order to be successful at the 30 level. So what you would do is you would go to Google, and I want you to type in YouTube Mac Prema. So I'll show you how it would work. So here in Google, in a search engine or search bar, type in YouTube Mac Prema and hit enter. From here, this link will take you to his channel. And once you're on his channel, where you really want to go is to playlists. Once you're in his playlists, find the playlist for Math 20-1 Trigonometry. He has 24 videos in here. And if I go back here, this page would be videos 211, 212, and 213. Now he does different examples. So if we were in class, I'd be going through this lesson with you, and then I would say, okay, tonight you need to go home, and these 3 videos you'd be watching as homework. And if I go back to his YouTube page, here are the 3 corresponding videos. Okay, so just really important that as we go through that because we're doing this at home, that you are taking your time and watching those videos. Remember that the advantage of me making this video for you is you need to pause so that you're not getting behind in the writing, that you're thinking about this. As we go through examples, you could rewind, look at an example, listen to as many times as you need. Okay, so let's get started. What we have here, so anything that I draw off to the side, please make sure you're writing that in your workbooks. I have what's called a Cartesian plane. And a Cartesian plane has a horizontal x-axis and a vertical y-axis. And what happens is the x-axis, we're going to say that that's 0 degrees. And then y up here lies at 90 degrees. Then over here would be 180 degrees, 270 degrees, and then one complete rotation around a circle would be 360 degrees. And in 20-1, we are going always counterclockwise from 0 to 360 degrees, okay? So from here, what we're going to be doing is we're going to be making angles. So what we have first is something called an initial arm. And the initial arm, where it lies, is on the x-axis, and we should actually write it lies on the positive side of the x-axis. Okay, so right here, I'm just going to change this. Okay, so a few things. This point here, that coordinate would be 0, 0, and we call that the vertex. Then I have an initial arm, which lies on the positive x-axis. What we could do is we could take that initial arm and we could rotate it either clockwise or counterclockwise, but in 20-1, we will go counterclockwise, and we could rotate it through the quadrants. Where that initial arm stops, we call that now the terminal arm. So that's where the arm terminated, so we now call it the terminal arm. What happened from where our initial arm was on the x-axis at 0 degrees, the angle opened up, and this is what we call our angle in standard position. I'm going to denote that using theta. And we know that theta, this angle, which we call the angle in standard position, it's between 180 and 270 degrees. So let's just say that it terminated at 210 degrees. We would say that theta is equal to 210 degrees, or my angle in standard position is 210 degrees. So theta is equal to 210 degrees. Okay? So again, here's what I just sort of explained. So 0, 90, 180, 270, 360. That is my terminal arm. And if that's 210 degrees, this is theta, and theta would equal 210 degrees. Now what happens is my Cartesian plane is divided into 4 quadrants. We always start with quadrant 1, which is the top right-hand quadrant, and we write our quadrants going counterclockwise. So from quadrant 1, we would go to quadrant 2, here's quadrant 3, and this would be quadrant 4. Okay? Now with that information, we'll be able to do class example 1. So what it says is sketch the rotation angle. So the rotation angle is another word for the angle in standard position. It's just taking that initial arm and rotating it. Sketch the rotation angle in standard position and state the quadrant in which the angle terminates. Okay, 120 degrees. We know that 120 is between 90 and 180. So 120 degrees, I'm going to draw my initial arm, and then that arm would open up and it would terminate here. So my angle in standard position would look like this. That I will write 120 degrees. And then over here I could say theta is equal to 120 degrees. And we are terminating in quadrant 2 would be our answer. 309 degrees. So we start at 0 and we're going to rotate past 270 to, let's say, 309 is here. Draw your terminal arm. 309 degrees. That is my angle in what we call standard position, and it's between 270 degrees and 360 degrees, and I've terminated in quadrant 4. 17 degrees. So we know that that's between 0 and 90, and it's going to be a small angle. So my initial arm would open up just a little bit to 17 degrees. That's my angle in standard position. So theta, I could write in there, and theta is equal to 17 degrees. And where did I terminate? I terminated in quadrant 1. Class example 2 says, draw the rotation angle in standard position. And what we're going to omit from class example 2 is we're going to omit B. So this would be done in 30-1. And the reason why we're going to omit it is because it's a negative angle, and in 10C we're only going to deal with positive angles. So a rotation angle of 150 degrees. So we know that 150 is between 90 and 180, and they actually have it drawn. So that would be my terminal arm. That would be 150 degrees. There's my angle in standard position. Okay. 510 degrees. So if I said to students, okay, well, where's 510 degrees? One complete rotation is 360 degrees, right? So if I go once around a circle, that's 360 degrees. So if you take 510 degrees And what I'm just going to show you is I'm going to subtract 360. So I'm going to go once around the circle. So 510 degrees minus 360, that's equal to 150 degrees. So what I want you to see is this. If I go once around the circle, that is 360 degrees. And then if I add to that 360 degrees and I go an additional 150 degrees, I have gone 510 degrees. So I went once around the circle to get to 360 degrees, and then I'm going to go 150 degrees more, and I would get here. This angle in standard position would be 510 degrees. So again, once around the circle it went for 360 degrees, and then it went 150 more degrees, and it terminated here at 510 degrees. Now, what I want you to look at is I want you to look at where 510 degrees is and where 150 degrees is. And what I want you to notice is that those angles terminated at the exact same position in quadrant 2. So both angles terminated at the exact same position in quadrant 2. What we call 150 degrees and 510 degrees, they are what's called coterminal angles. And it's angles with the same terminal arm. So I'll give you another example if you didn't quite get that. Let's say I said, where would, let me think of an example, 200 degrees be? Okay, so if I said, show me where 200 degrees is, so theta is equal to 200 degrees, you would say, okay, this is 180, this is 270, 200 degrees, if I start here, I would open up and I would go maybe to here. That would be 200 degrees. Well, what is coterminal with 200 degrees? So again, coterminal means it terminates at the exact same position. And the answer for an angle that would be coterminal with 200 degrees would be 560 degrees. Okay, so let's see why. 560 degrees. If I said, well, sketch 560 degrees, you'd say, okay, well, I don't quite know where that is, but I know that one complete rotation is 360 degrees, right? So if I go one complete rotation, I've gone 360 degrees. Well, if you subtract 500, what did we have? 560 degrees minus 360, because you went one complete rotation, that what you have left is to go 200 degrees. So once we're back at the start, 200 degrees, that would be 180. This would be 200. That terminal arm would be 560 degrees. And it has the exact same, it terminates in the exact same place as 200 degrees did. So these two are what we would call coterminal angles. So that's a pretty big concept in 30-1. Okay, let's do this last class example, and then I will give you some homework. So it says, and then there'll be lesson or part 2 after you're done this homework. So point P lies on the terminal arm of an angle theta. Draw the angle theta in standard position. So point 2, 4. So we know that all points on a Cartesian plane are x, y. So my x would be at 2 and my y would be at -4. So I'm going to write my x-axis. Here's my y-axis. X is at 2, so 1, 2, and y is at -4. -1, 2, 3, 4. Put a point there, and that point, they say call it letter P, and that point, the coordinates are 2, -4. So then what it says is point P lies on the terminal arm. So now what I need to do is using my ruler, I'm going to draw that terminal arm going through point P. Okay, So it says point P lies on the terminal arm. So this would be my terminal arm, and there's point P. Draw the angle in standard position. So from 0, that angle opened up and it terminated there, and that would be the answer. Okay, let's do this second one. So they want point P to be at x is -5 and y is -1. So there's my x-axis, here's my y-axis. Y is -5, or sorry, x is -5. Here's where x is 0, -1, 2, 3, 4, 5, and y is -1. The point would be right there. Then what I need to draw is a terminal arm going through that point. I'll use the ruler. So there's my terminal arm going through this point here. We're going to call that point P, and the coordinates of point P is at -5 and -1. And if I was to draw the angle in standard position, this would be my angle in standard position. That's theta. And if I said, well, guess like what would a good estimate of theta be? It's past 180 degrees, but it's going to be somewhere between 180 and 270. Okay, what I want you to do, that's it for part 1. I want you to go to your homework and I want you to do questions 1 and 2 in your homework. And then when you're done that, you could watch the second video, which will be part 2 for lesson 1.